So for quality control or analytical research lab, forced degradation is very important aspect. And there will be hardly any interview where this question is not discussed. So in today's talk, we are going to talk about three very important questions about the forced degradation. My name is Bhaskar Nabde and I am your pharma coach. So let us talk about these three important questions regarding forced degradation. The first one is, why do you conduct forced degradation study? Second one is, what is mean by mass balance? And third is, what is peak purity? Let us talk one by one. The first one is, why do you conduct forced degradation? Now listen very carefully. This one question can further trigger multiple questions. So if interviewer asks you, why do you conduct forced degradation? You must quote two important reasons behind it. The first one is to prove the stability indicating power of my analytical method. And the second one should be to understand the intrinsic stability of the compound or the drug substance. Now, when you talk about the stability indicating nature of the analytical method, don't you think interviewer is also going to talk about that term as well? So you must be ready for the sequential questions in any given interview. So force degradation may be just the beginning to enter into those multiple questions. So how you can prove that my method is stability indicating in nature? Now this question can be answered in a way that will help you to prove interviewer that you are a deep thinker. Now what is meant by stability indicating method? The method which can detect all the changes possible to happen during the stability or the shelf life of the drug product. So in case if you talk about an example, and I want you to give an example, like for example, if there is a paracetamol tablet, it comes with 2 years of the expiry period. So what happens to the paracetamol tablet if it is on the shelves for the 2 years? It can undergo a different temperatures conditions, different humidity conditions, and in case if the packaging material is allowing the influence because of the light, it can also undergo the photolytic degradation. Now what else can happen to the drug product which is stored onto the shelf? It can be also about the impact of different pHs. Now from where this pH impacts comes in, our atmosphere doesn't change that much in terms of the pH, but the very first nature of the drug product can bring the impact of the pH. For example, if my drug product is having a acidic pH, then certainly the drug substance can undergo the influence of the acidic pH. If my drug product is having alkaline pH for some reason, then my drug substance can experience alkaline pH conditions too. So the pH, in fact, the pH influence is not from the environmental side, but from very much of the drug product itself. Even hydrolytic degradation also can be because of the composition of the drug product. See, during manufacturing of the drug product, there may be the usage of water, or in case if not, there may be some amount of excipients which are carrying the water with them. So this water, which is part of those excipients, is now freely available for the drug substance to undergo hydrolytic degradation. So that is the reason, you must be able to answer when interviewer asks you what are the possible degradation that is going to happen in the complete expiry period of the drug product. So you started with the why do you conduct forced degradation? But that is not the end of the story. And I must advise you that you must be ready with the sequential chain of the questions. Now, this is about the one point that you talked about stability indicating nature of the analytical method. The second point you said that the intrinsic stability of the drug substance. I conduct force degradation study to evaluate intrinsic stability of the drug substance. Now, do you think that the interviewer is not going to further ask you what is meant by intrinsic stability? It is certainly going to ask you. So be ready and prepared for the second very natural questions. What do you mean by intrinsic stability of the API? The meaning of intrinsic word needs to be understood. Intrinsic and the extrinsic. These are the two different terms. Let us talk about what is meant by intrinsic. Intrinsic is something which is very first nature to anyone. So in case if the API itself is having, let us say, boiling point of 130 degrees Celsius, that is the intrinsic property of an API. Will you be able to change the boiling point of API from 130 degrees Celsius? Not at all. I mean, you can do that, but then the substance may be different. But if you want to have that API, the boiling point is going to be 130 degrees Celsius, of course, at the atmospheric pressure. Similarly, in case if that API is prone to degrade into the lower pH, you are not going to stop that from happening. It's very first nature of the API. Maybe it's functional groups making it to get degrade into the lower pH. Now, this is called as the intrinsic nature of the API, or this is called as the intrinsic stability of an API. So to understand, in which condition this API is unstable, this API undergoes degradation, is studied as a part of the forced degradation. Now the next question could be, why do you want to study the intrinsic nature of the API? You have studied your analytical method, which is found to be stability indicating. Stop there itself, right? You must be aware about the very important fact that the forced degradation is not only support to the analytical methods or during the method validation. This study can also help formulator to understand conditions in which your drug substance is stable, or understand and identify those conditions where the API is unstable. What is the impact of that? Let us say if you prove that this drug substance undergo photolytic degradation, that means this drug substance must be packaged or the drug product then must be packaged in such a container which can resist its exposure of drug substance or product to the light. In case if you prove that the drug substance is prone to degrade at lower pH, then can the formulation be made with the alkaline site? Absolutely yes. So these are the another benefits of understanding the intrinsic stability of the API. So just preparing for one question, like what do you mean by forced degradation is not enough. You have to further understand what are the questions within questions. And you must be ready for those questions. And in case if you are able to speak about those questions also, that proves your credibility that you are someone who has a deep knowledge about the forced degradation. Let us talk about the second question, which is what is meant by mass balance. Now, this the question which is discussed for several times, but it is your term now to explain in such a way that you will be able to build that credibility with the interviewer. So, the mass balance is you can talk about the definition of the mass balance. You can talk about why it is important. You can also talk about why the mass balance is higher or lower sometime. There can be situations where mass balance cannot be proved and justified. Now, these are the questions which are very much relevant to this very first question. Otherwise, just remembering the answer of mass balance is not going to save you from the nightmare. You have to understand the question within question and make a chain of those questions and make sure that you know the answer to all these questions. So let us understand and talk about how you are going to explain the mass balance. Now there are two terms, one is mass and another one is balance. So in case if you prove that the initial mass at the beginning of your degradation is equal to the mass of the degradation product plus API at the end of degradation. If these sides are equal, then the mass balance is been proved. For example, if the assay of undegraded sample is 95% and if there is 1% impurity present before its degradation. Now what is the total content? Is 95 plus 1%. Now when you start a degradation, for example, you are conducting the acid hydrolysis and at the end of acid hydrolysis, you are going to quantify degradation products using related substances method. And similarly, you are also going to quantify the assay of your API or the drug substance. So for example, I found assay is equal to 90% and the 6 percentage are the another degradation impurities. Now what is the equation? In first equation, before starting the degradation, I have 95 assay plus 1% impurities, 96%. When the sample has been degraded, 90% is assay found and 6% are impurities. Again, 90 plus 6 becomes 96%. Now this is called as the perfect mass balance, right? Total impurities plus API assay is at the beginning of mass degradation or before the mass degradation is equal to the total number of impurities plus API after the degradation. This is nothing but the mass balance. So the next important question will be, why do we want to conduct mass balance? So the answer to this question should be, the mass balance will help me to understand whatever degradation is happening during the process is also getting detected by my analytical method. I mean, if there is mass balance established, that also indicates whatever degradation is happening, it is getting measured and quantified by my detection technique. It can be HPLC or gas chromatography. So that is the very first reason why I must conclude onto the mass balance. Now the next question could be, now you said that you need to understand the mass balance. I completely agree with this. Interviewer will ask you, but will you always achieve the mass balance? And for to this, the answer could be no, I may not. So the next question is going to be, what are the probable reasons for the mass balance failure? Now you have to ready for this question. See, because the deeper you go, the better you are proving your credibility, right? The interviewer is just thinking that you are the right person for this position and the opening. So don't just get yourself at the beginning of the question. Okay, let me study about the mass balance and forget about everything about it. Sequential questions are very, very important. If you are able to answer sequential questions, you will easily crack the interviews. So we are at what are the reasons for the mass balance failure? So study about it. It can be about the different response for the degradants than the API. So what you are assuming practically, ideally, that the response is going to be similar. But is that the actual practical case? The response of degradation products can be lower or can be higher also as compared to your drug substance or the API. So this is the number one reason why you can have the lower or higher mass balance. The another reasons could be the precipitation of impurities. The another reason for higher mass balance could be the formation of adduct with the excipients. The another reason for higher mass balance could be the degradation products leaching out of your containers. Now identify the list of such reasons why there is a possibility of not achieving the mass balance. Now the next question interviewer could ask you, okay, I understand the reasons for the mass balance failure. Can you live with a study where the mass balance has not been justified? Now this is the question which is going to test your thinking abilities. So to answer this, you have a reason that's been said that these are the several reasons for the mass balance failure. But does the regulator accept this situation is a very important question. To this question, you must say that there is a possibility that regulators can accept the situation of not having the appropriate mass balance with the scientific justifications. Now, what is meant by scientific justifications? The scientific justification can be built based on to the investigation done for each and every failure study. For example, if you are not able to achieve mass balance into thermal degradation, so you need to investigate. You have to understand what are the reasons for not achieving the mass balance. And then going through the hypothesis that this could be the reasons for the lower mass balance or higher mass balance, whatever it may be. And then I have conducted this 1, 2, 3, and 4 experiments. And out of these experiments, I concluded that the mass balance in thermal degradation may not be achieved. Maybe because of the impurities which are not having the good amount of response into the detection technique that I have selected. So the failure in mass balance for certain cases is also be justifiable and can get accepted by the regulators. But you must not just stop there. Once you conduct the experiment and there is a mass balance failure observed, oh, see, here is the mass balance failure. So sorry, no. You have to investigate it on the scientific grounds. You must make an effort. The regulators must see the efforts made by you. So that way, your mass balance, even though it is not meeting your acceptance criteria, can also get accepted. Now the another question, as just I talked about the acceptance criteria, it can be about what is the acceptance criteria for the mass balance. Now if you look at any ICH guideline or FDA, EMA guideline, you will not find acceptance criteria for the mass balance. So you have to rely on to your own experience, the industry practices. So think about what is the answer for this acceptance criteria. Now the third question is very interesting. That is called as what is mean by peak purity. The peak purity means what? You are actually talking about the spectral purity. Means you have a spectra collected across a peak from its start to the end. Now what is the peak purity? You are going to assess that all the spectra across the entire peak are similar. They are not different from one another. And if you prove that the spectra are similar across the peak, that means the component that you are measuring as a peak is one and the same because all the spectra are similar and hence they must be belong to one and the same component. If they belongs to one and the same component, that indicates that there is no co-elution happening within this peak. I prove that if the peak is spectrally pure, there is an absence of co-elution. I am talking about only and only one compound as a part of this peak, and that is the very much reason to understanding the peak purity. You have to justify that my method is specific in the nature. That means there is no interference coming up from the known or unknown compounds. There is none other than co-eluting with the interested compound. If I talk about related substances, I must measure the peak purity for the impurities plus APIs. The next question is going to be, how do you measure peak purity? And now there can be a different methods for different application softwares. So the Empower software talks about the purity angle and purity threshold. The Chromulant talks about the some different terms. OpenLab can talk about some another terms. So here the advice is, whatever software you are using, maybe Chromeleon or Empower, make sure you have a detailed idea about the peak purity measurement. So these 3 points are very important. And I'm also going to give the link for the videos that I have prepared, which will help you to understand these 3 questions in a very deeper way. Thank you so much, and go to the description and identify those 3 important links to further study these 3 questions. Bye bye.